In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. IUPAC name for each compound. So these are alcohols. We want to locate the alcohol, identify the carbon atom that is connected to it. I just make a dot here so you can see where it is. And then we need to find the longest chain that goes through the molecule. It looks like 5 carbons here is the longest chain. We count them out. There's 1, 2, 3, 4, 5. Okay, so this is a pentanol. Now we number the carbons, and we number the carbons such that the alcohol receives the lower numbering. So we want to number from right to left in this case here. Okay, so we got the alcohol attached to carbon 1. Next, we want to number and name the substituents. So we've got a methyl group at carbon 3. We have another methyl group at carbon 3. And then we want to alphabetize the substituents. Here, of course, there's only one substituent, so we don't need to really worry about this. This is going to be 3,3-dimethyl. Remember, when you have 2 methyls, you need 2 numbers for each of them, and we use di to shorten this out. So we wouldn't say 3-methyl, 3-methyl. We would say 3,3-dimethyl. And it's, as we mentioned before, pentane is the longest chain, so we would write pentan. Okay, and the alcohol is attached to carbon 1, so it would be pentan 1 all. All right, so that's the IUPAC name for this problem 9.2 part A. All right, now here we have a ring. So let's look at the ring carbons here, which form a nice 6-membered ring. And we want to, the numbering, of course, the alcohol would be at carbon 1 always. And we want to number it so that that methyl group lies at a lower carbon numbering. So we would number this, looks like counterclockwise here. And so this is on a wedge. We have a methyl group at carbon 2, so this is 2-methyl. Okay, and we want to assemble the name here. So the name here would become cis, because we have 2 wedges, so this would be cis. Okay, and there's a methyl group at carbon 2, so cis 2-methyl. Okay, and we have cyclohexane, and we have an alcohol at carbon 1. Now, when you have a ring, the alcohol is always assumed to be at carbon 1. If we just have one functional group in the ring, it's always assumed to be on carbon 1. So we wouldn't need to say cyclohexane 1 all. We can just say cyclohexanol. So there's actually no numbering here for the carbon 1. Okay. So cyclohexane 1 all, we don't need to say that, it would be cyclohexanol. All right, so that's the IUPAC name for part B. For C here, once again, the procedure: locate your alcohol, find that carbon that's attached to the alcohol, and now we want to find the longest chain that contains this dotted carbon. So if we count, we could count 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like that's longer. So I'll highlight the longest carbon chain that I've found. All right, and we want to number these carbons so that the alcohol will be at the lower numbering. So again, here we want to kind of number starting from the bottom, going up, and moving to the left. And then we want to number and name the substituents. So it looks at carbon 5, we have an ethyl. All right, carbon 5, we have an ethyl group. And at carbon 6, we have a methyl group. And carbon 3, again, is where the alcohol is bonded. Okay, 9 carbons is nonane. Okay, nonane is an alkane with 9 carbons. To assemble the name, we alphabetize the substituents. So ethyl comes before methyl. So the name of this would be 5-ethyl, 6-methyl. Okay, and as we discussed, the parent chain is nonane, so it would be nonan. Okay, and the alcohol is at carbon 3, so we would put 3-all. Okay, so 5-ethyl, 6-methyl, nonan, 3-all. Okay, that's the IUPAC name for part C. Thanks for watching.